A very good evening to one and all. Let me introduce myself Jeshwan. I am from the Department of Electronics and the Communication Engineering. I am pursuing my graduation in the Srinivasa Ramanujam Institute of Technology. Today's class I could like to discuss about the calculation of poles and the residues of a complex function in the course of probability and the complex variables. So the topic is the calculation of poles and the residues of a complex function. So we taken one of the example problem, that is f of z equals to z square plus 2z by z plus 1 whole square into z square plus 4. So here is the solution for the example problem. So the solution, so the first of all we have to write the poles of a f of z or z plus 1 whole square into z square plus 4 equals to 0. We have to make the these two terms into two parts. We have to separate that equals to 0. So z plus 1 whole square that equals to 0. So the z value becomes minus 1. It is the pole of order 2, and the next is z square plus 4 that equals to 0. So it becomes z square minus 2i whole square that equals to 0. So then it becomes z plus 2i into z minus 2i equals to 0. So the plus 2i and minus 2i it becomes to plus or minus 2i are the simple poles. So the residue of a f of z at z equals to 2i. So the residue f of z equals to 2i, it limit tends to z tends to 2i, z minus 2i into f of z. So it becomes limit z tends to 2i into z minus 2i into z square plus 2z by z plus 1 whole square z plus 2i z minus 2i. So the z plus 2i and z plus 2i get cancelled, and we get limit z tends to 2i, and then 2 z square plus 2z by z plus 1 whole square z plus 2i we can get. So we have to divide these two terms. It means the 2 2i whole square plus 2 into 2i by 2i plus 1 whole square 2i plus 2i that equals to the 2i whole square plus 2, I mean the 2 into 2i, it becomes 4i square plus 4i by 4i. We have to get the common 4i. We can get the 4i square, I mean 4i square plus 1 plus 4i. So get the value minus 4 plus 4i by 4i into minus 4 plus 1 plus 4i. We can get the value 4i minus 4 by, we have to take the common one, that is 4i, the 4i minus 3. We have to get the minus 4 common. So the extra term is 1 minus c by minus 4i into 3 minus 4i 4e. The minus 4 get cancelled. So we can get the minus 1 minus I, sorry, 1 minus I into 3 plus 4i by I into 3 minus 4i into 3 plus 4i, and then we can get the final value, that is 1 minus I into 3 plus 4i by I into 9 minus 4i whole square, that equals to the, we have to, I mean we have to multiply the 1 minus I into 3 plus 4i. We can get the 3 minus 3i plus 4i minus 3i whole square. So in the I, we have to take the I common, and then the 4i whole square, it becomes 16i whole square. We can get the 3 plus I plus 4 by I into 9 plus 16. So the 3 plus 4, it gets it is equal to 7. The extra term is I. 7 plus I by the 16 plus 9, it becomes to 25. So I 25i, 7 plus I by 25i. So we have to take the 25, I mean 1 by 25 we have to get the common, and the extra term is minus 7i plus 1. So in this one we have to the minus 7i goes that side, means it becomes plus 7i. So 1 minus 7i by 25, this is the final answer. So and then to calculate the, I mean to calculate the residues of f of z at z equals to minus 2i. In a last in the last we take the f of z at z equals to 2y. Now we are taking the f of z at z equals to minus 2y. So in this one the limit z tends to minus 2y. So the z plus 2i f of z, we get the value minus 2i whole square plus 2 into minus 2y by minus 2i plus 1 whole square minus 2i into minus 2i. It becomes to 4i whole square minus 4i, and 1 minus 2i whole square into minus 4i. It becomes to minus 4i by minus 4i into 1 plus 4i whole square minus 4i. It becomes to minus 4 get cancelled, and we can get the final answer, that is 1 plus I by I into minus 3 minus 4i, and it is equal to 1 plus I by minus I 3 plus 4i, and it is the final answer. I mean, the next step is I into 3 plus 3i minus 4i minus 4i whole square. We are taking the I common by 3 square by 4i whole square. The 3 square means 9, nothing but 9, and 4i whole square means nothing but 16i square. So the final answer is I into 7 minus I by 9 plus 16. 9 plus 16 means nothing but 25. I mean, we have to multiply the 7 minus I in 7 minus I with the help of I. So the 7i minus I square it becomes by 25. The final answer is 1 plus 7i by 25. And then to calculate the resonance of f of z at z equals to minus 1, the pole of order 2. So we are taking the resonance f of z at z equals to minus 1. So the 1 by 2 minus 1 to the power of 1, limit z tends to minus 1. We are differentiating the above equation, that is z plus 1 whole square f of z. So the next step is a limit z tends to minus 1. We have to differentiate the z plus 1 whole square f of z plus 1 whole square z square plus 2z it becomes, and then by z plus 1 whole square z to the power of plus 4. And the next step is limit z tends to 1, z tends to minus 1, divided d by dz z square plus 2z by z square plus 4. And then the next step is limit z tends to minus 1, it becomes z square plus 4 into 2z plus 2 minus 2z into z square plus 2z by z square plus 4 whole square. And then again the another step is 1 plus 4 into minus 2 plus 2, it becomes 0, and then plus 2 into 1 minus 2. 1 minus 2 means nothing but minus 2 by minus 1 whole square minus 1 whole square plus 4 whole square. It becomes 0. I mean 0 minus 2 by 5 square. 5 square means nothing but 25. 0 minus 2 means minus 2 by 25. The final answer is the minus 2 by 25. Thank you for giving this opportunity to introduce this topic for you.